Hello and welcome to another video. In this video, we're going to be working on rearrange array elements by sign. And in the problem, you're given a zero-indexed integer array nums of even length, consisting of an equal number of positive and negative integers. You should rearrange the elements such that the modified array follows the given conditions. Every consecutive pair of integers have opposite signs, and for all integers with the same sign, the order which they're present in nums is preserved. The rearranged array begins with a positive integer. So return it. And let's take a look at the examples. So in the first example, we have this. And you want to have 3, then the next positive integer, you want to have positive, negative, positive, negative, positive, negative, but the order of the positives and negatives is preserved. So the positive should be 3, 1, 2, which it is 3, 1, 2. And the negatives are negative 2, negative 5, negative 4, negative 2, negative 5, negative 4. Second one, same kind of thing. You want to have the positive number first, negative number second. So essentially, your array looks like, if you have some array, your result should always be, positive, negative, positive, negative, positive, negative, and so on, right? So like positive, negative, so on. It should be the whole array like this. So how do we do that? And we can do this in a separate variable. So it's pretty easy to do this, actually. What we can do is we can just have pointers to where we need to be putting numbers in. And that's the easiest way to do this. So what we can do is we know that we can have 2 colors for this. So let's say the green arrow is going to be positive, and let's have another color, white arrow, or not white, blue, we'll make it negative. And let's write it like this. Oops. Can't make an arrow. Okay. So basically, we can just go through our numbers, and we can put it into wherever the next available number should go. So if we have a positive number, like if we go through our numbers, like let's go through this thing here, 3, 1, negative 2, negative 5, 2, 4. So 3, 1, negative 2, negative 5, 2, 4. Yeah. So for these numbers, first we check. We can just go through every single number. So is 3 positive or negative? It is positive. So it'll go where the positive number should go, which it should be positive, negative, positive, negative. So these are the initial locations. So because 3 is positive, we'll put 3 here. Now we know the next positive number needs to go 2 indices down, right? Because it's positive, negative, positive, negative, positive, negative. So every positive will go to the next 2, 2, 2, 2. Then for 1, it needs to go where the positive is. Positive is green, so 1 will go here. Negative 2. Oh, and by the way, before we go to negative 2, so we put in a 1, and then where should the next positive number go? It should go right here. 2 indices down again. Then negative 2 should go where the first negative number should go. So negative 2 should go here. And now that we put in a negative number, where should the next negative number go? It should go 2 down over here. And so negative 5 goes over here. And the next negative number should be 2 down, like this. And then we have 2, and I think I screwed this up. Let's see, 2, negative 4. So 2 should be positive. So we're going to put in a 2 here. And then the next positive number should go over here. And negative 4 should be negative. So negative 4. And this is blue. And that's kind of the idea. You just have 2 pointers of where like the positive and negative number should go. And anytime you place one of them, you just increment one of them by 2. And in the end, you're going to have all your numbers exactly where they need to be because you know they need to be positive, negative, positive, negative, positive, negative. So this is by far the easiest way to do it. There's other ways, but this is by far the easiest, just having 2 pointers. So this is the way we're going to code up. So we'll have 2 pointers. The positive will start at index 0. The negative will start at index 1. And then every time we place a number, we can just move whatever, like if it's positive, we'll move it by 2. If it's negative, we'll move it by 2 as well. And then by the end, we'll have our whole array. So we're going to initialize an array of this length, and we will fill in numbers as we go. So let's code that up. So we're going to have result. We can just initialize it to whatever we want, null, 0, times length nums. We'll have our 2 indices. So positive, negative. Positive will start at 0, negative will start at 1. And now we just loop through nums. So for num in nums, if num is negative, so less than 0, then we will put it in the negative. So result negative. equals num and increment negative by 2. Otherwise, num has to be positive, so result positive equals num increment positive by 2. And finally, just return result. And that should literally be it. So a very easy one. I don't know why I have this timer thing. Yeah, so very easy. And this is by far the easiest way. There's other ways, but this is the easiest way to do it. So this is going to be time O of n and space of 1, because we do need to have like a result in another variable. We don't want to override input. I don't know if there's a way to do it if you override input, like an in-place solution for this. Maybe there is. It would be kind of tricky. But the non-in-place one is really trivial. You just do this kind of thing, 2 pointers where you need to write things. And so you could also implement this. I hope you can see the pattern now. Like if you needed to have 3 types of numbers, you can use 3 pointers and so on. So you can make this like infinitely scalable to the number of pointers if you know your pointer needs to be like every other number or every third number or whatever it is. And yeah, that's going to be all for this one. If you did like this problem, then please like the video and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.